A vase has water with a depth of 6 centimeters and needs to be filled to a depth of 32 centimeters. The cross-section of the vase is modelled by the curve AB, where x is equal to 15 take away 4 cos pi y over 40 for y between 0 and 40. And this curve is revolved about the y-axis. All dimensions are in centimeters. Give all answers in this question to the nearest appropriate unit of measurement. Calculate the volume of water that needs to be added to increase the depth of water from 6 centimeters to 32 centimeters. In other words, we need the volume of this section. So it's a volume of revolution about the y-axis. So v is going to be pi times the integral of x squared dy. Let's fill in what we know. So that's going to be pi times the integral from 6 to 32 of 15 minus 4 cos pi y over 40 squared dy. And we're just going to do that on the class pad. We can see that that gives us 18,107.94, and it says appropriate accuracy. Since the original figures were given just to the nearest whole number, we should give this to the nearest whole number. So 18,108 cubic centimeters. Josie, an interior designer, uses a hose to add water to the vase. This hose has a water-saving device that regulates the rate at which water flows into the vase. This rate is given by dV dt is 300 e to the negative v over 12,000, where v of t is the volume of water poured into the vase after t seconds of flow. If Josie has already poured 6,000 cubic centimeters, use the increments formula to calculate an approximation for the volume of water she will pour in the next 5 seconds. So we can use delta V is approximately dV dt delta t, and delta t is 0.5, so that's going to be equal to dV dt evaluated when V is 6,000 multiplied by 0.5. So here's our dV dt. That is going to be 300 e to the negative 0.5, 6,000 over 12,000, multiplied by 0.5. So we've got 300 multiplied by e to the negative 0.5, and then we'll multiply that by 0.5, and we get 90.98. And I would probably round that to 91 cubic centimeters. The measurements that we had were all to the nearest whole number, apart from this 0.5 seconds, so we might make an argument here for 1 decimal place, but 91 seems appropriate. To prevent an overflow of water, the device can be calibrated to switch off the flow after a set length of time using an inbuilt timer. Calculate the rate of flow into the vase at the instant when the depth becomes 32 centimeters. In other words, when it's full. So that means we're after dV dt, but that's 300 e, and we know this was to the negative v over 12,000. Well, v, when it's full, is our answer to the first part of the question, 18,107.94. So we can calculate this, and it gives us 66.34. Once again, the original measurements were to the nearest centimetre. So despite the fact I've used this to 2 decimal places here, remember we rounded that in the first part of the question. I just thought I'd use a more accurate figure here. So we should give the answer as 66 cubic centimetres per second. Using separation of variables, obtain the defining rule for V of t. So we know that dv dt is equal to 300 e to the negative v over 12,000. So separating and integrating, note that this is e to the negative v over 12,000. On the other side, that will become e to the v over 12,000. Think of multiplying both sides by e to the v over 12,000. And the integral of that dv would be equal to the integral of 300 dt. So if we integrate this, we would get 12,000 e to the v over 12,000. You think about integrating this, the exponential will stay the same, and then we need to divide by 1 over 12,000, the differential of the inside. Dividing by 1 over 12,000 is the same as multiplying by 12,000. And that's going to be equal to 300t plus c. But we know that v equals 0 when t equals 0. So e to the 0 is 1. So that gives me 12,000 on the left, and on the right, if t is equal to 0, we just get c. And so we have that 12,000 e to the v over 12,000 is equal to 300t plus 12,000. So e to the v over 12,000 would be equal to 0.025t plus 1. So that was dividing through by 12,000. Now we could take logs of both sides and have v over 12,000 take natural logs. So if we do the log of this one over here, we do the log of that, then the log and the exponential function are inverse functions. And so we just end up with v over 12,000 is the natural log of 0.025t plus 1, and therefore v is equal to 12,000 into the log of 0.025t plus 1.